Let's dive deep into this. Toxic bloom event. 252 million years ago, the ocean stopped being a place where things lived. Not because an asteroid struck, not because a volcano buried it in ash. The sea turned on itself, manufacturing a poison so complete and so silent that 96% of every species swimming, crawling, or drifting through it simply ceased to exist. Geologists call it the Great Dying. The name is not an exaggeration. Before this moment, Earth's oceans had been teeming with life for hundreds of millions of years. Trilobites, coral reefs, vast schools of armored fish, entire ecosystems of extraordinary complexity had built themselves across the seafloor. The ocean was not fragile. It had survived impacts, ice ages, and volcanic winters. It had always recovered. There was no reason to believe this time would be different. There was every reason to be wrong. The mechanism was the Siberian Traps, a volcanic province that expelled an estimated 3 million cubic kilometers of lava over roughly 2 million years, flooding the atmosphere with carbon dioxide and sulfur. Ocean temperatures climbed, oxygen levels in the water collapsed, and in the deep, oxygen-depleted layers, something ancient and chemical stirred back to life. Hydrogen sulfide, a gas lethal to aerobic organisms, began erupting from anoxic ocean depths in what researchers now call a euxinic event. Geologist Lee Kump of Penn State published influential work proposing that hydrogen sulfide concentrations reached atmospheric levels toxic enough to kill land animals as well. The poison didn't stay in the water. It rose. The evidence of this event is pressed into rock layers across the entire planet, a distinctive black carbon horizon that geochemists have traced from China to Greenland to the floors of ancient seas. The same signature, everywhere, simultaneously. Recovery of marine life took approximately 10 million years. 10 million years to rebuild what the ocean erased, in what the geological record shows as a geological instant. The ocean didn't need help to become the most lethal environment on Earth. It had everything it required already dissolved within it. The chemistry was always there, waiting for the right conditions to wake up. Scientists studying modern ocean warming have noted that the same deoxygenation processes responsible for the Great Dying are measurable in present-day deep water today. The ocean has done this before. The question is not whether it can do it again. The question is what a warning sign even looks like when the weapon is invisible. Cold ocean shock. 12,900 years ago, the North Atlantic dropped approximately 15 degrees Celsius. Not over centuries, not over millennia, over decades. Settlements that had existed along its coasts for thousands of years were abandoned so completely that we are still finding their bones preserved in peat bogs. Their tools scattered across what is now open seawater. Their fires extinguished in a cold that arrived faster than any human community could adapt to or understand. The event is called the Younger Dryas, and it represents one of the most dramatic climate reversals in the record of human prehistory. The last ice age had been retreating. Temperatures were rising. The land was greening. For the people living along the margins of the North Atlantic, the world was becoming more habitable with every generation. Then, in what ice core records suggest was as few as 3 years, everything reversed. The trigger, according to research from the GISP-2 Greenland Ice Core project and decades of oceanographic study, was the catastrophic draining of glacial Lake Agassiz, a body of fresh water larger than all of today's Great Lakes combined. When its ice dam failed, a volume of cold, fresh water flooded into the North Atlantic so suddenly that it interrupted the Atlantic meridional overturning circulation, the vast conveyor belt of ocean currents that regulates temperature across the entire northern hemisphere. The conveyor slowed, then it stopped. Sea surface temperatures across the North Atlantic fell by an estimated 10 to 15 degrees Celsius. Marine ecosystems collapsed. Species distributions shifted by thousands of kilometers within a few generations. What makes the Younger Dryas genuinely terrifying is not just its speed, but its ending. After roughly 1,200 years of cold, the warming at the close of the event was equally abrupt. Greenland ice cores show temperatures rising by as much as 10 degrees Celsius within a decade. Something switched the ocean off. Then something switched it back on. The mechanism in both directions remains imperfectly understood. Modern monitoring stations have been documenting a measurable slowdown in the Atlantic meridional overturning circulation for 2 decades, a trend confirmed in research published in Nature in 2021. The system that stopped once in human prehistory and rewrote the map of survivable civilization is showing early warning signals that no climate model fully agrees on how to interpret. The ocean conveyor does not announce its intentions. It simply slows, and then one day it doesn't turn. Pressure collapse. 8,150 years ago, approximately 3,500 cubic kilometers of seafloor off the coast of Norway collapsed into the deep ocean in a single event. The wave it produced was not a ripple. Geological evidence preserved in coastal sediment layers across Scotland, Norway, Iceland, and the Faroe Islands documents a wall of water estimated between 10 and 25 meters in height that struck without warning. The people living on the coasts had no word for what was coming. There was no time to develop one. The Storegga Slide, as geologists now call it, occurred at a moment when the map of northern Europe looked nothing like it does today. Between Britain and continental Europe lay a landmass the size of modern Germany. Archaeologists call it Doggerland. It was inhabited by Mesolithic hunter-gatherers who had lived there for thousands of years, following game across river valleys and wetlands that are now submerged beneath the North Sea. Doggerland was not a myth or a legend. It was a home. Fishing trawlers still pull up its animal bones and its people's tools from the seabed today. The mechanism behind the Storegga collapse is believed to involve methane hydrates, frozen structures of gas and ice that form at extreme pressure along continental shelves. As ocean temperatures rose following the end of the last ice age, those hydrate deposits destabilized. The seafloor that had been locked in place for millennia became suddenly, catastrophically loose. Archaeologist Sue Dawson and colleagues identified the tsunami deposit in Scottish archaeological sites, a distinctive marine sand layer found far inland, above the remains of settlements that were subsequently abandoned. The wave reached places no wave should have reached. The full human cost of the Storegga event is something archaeology is still measuring. The tsunami did not destroy Doggerland alone. Combined with the steady sea level rise that had been swallowing the landmass for generations, the Storegga wave accelerated the final inundation of an entire inhabited world. A civilization unnamed in any history disappeared beneath the water and was forgotten so completely that modern science only recognized it existed in the late 20th century. Methane hydrate deposits of the type implicated in the Storegga Slide are distributed across continental shelves globally and are considered one of the most significant unknown variables in modern ocean warming projections. The collapse of 8,000 years ago was not an isolated anomaly in the geological record. It was a mechanism that the ocean has demonstrated it can use. Doggerland is still down there, 30 meters beneath the surface of the North Sea, waiting to be fully mapped. The ocean kept everything. It simply stopped telling us where to look. Seafloor break. 66 million years ago, an asteroid approximately 10 kilometers wide struck the Yucatan Peninsula with the estimated energy of 10 billion Hiroshima bombs. The impact generated seismic waves equivalent to a magnitude 11 earthquake, shattering fault systems across the entire planet. What history books tend to focus on is the dust cloud, the darkness, the collapse of photosynthesis. What they rarely discuss is what happened to the ocean floor. The seafloor fractured, and what came up through those fractures was a second catastrophe, arriving from below. Before the impact, the ocean had sustained complex life for hundreds of millions of years. Marine ecosystems at the close of the Cretaceous period were among the most diverse in Earth's history. Mosasaurs, ammonites, vast carbonate reef systems, microscopic foraminifera that covered the ocean floor in layers of calcium carbonate sediment accumulated across hundreds of millions of years. The sea was full. Then the sky opened. Research documented by geologist J. Malash and others has shown that the seismic energy of the Chicxulub impact triggered massive underwater landslides globally and cracked open hydrothermal systems along the mid-ocean ridge. The Gulf of Mexico seafloor preserves evidence of impact-generated waves in sediment deposits called ejecta-bearing turbidites that traveled thousands of kilometers across the ocean floor. A study published in Science Advances in 2020 documented evidence of a wave estimated at 1,500 meters in height generated within the first hours of the impact, one that scoured the seafloor of what is now North Dakota. Ocean acidification followed within weeks, so severe that calcium carbonate sediment began dissolving from seafloors globally. Scientists who study the deep sea sediment record of this event have given the post-impact ocean a name, the Strangelove Ocean, a term coined by oceanographers Brucker and Peng to describe a sea that had temporarily forgotten how to sustain life. Below the iridium layer that marks the boundary of the extinction event, the fossil record of marine life is extraordinarily rich. Above it, there is nothing. The silence in the sediment is absolute, and it lasts for hundreds of thousands of years. The asteroid lasted seconds. The seafloor remembered it for nearly 1,000,000 years. Every calcium carbonate shell, every coral structure, every microscopic organism that built its body from the chemistry of the sea found that chemistry had been poisoned from above and fractured from below simultaneously. The ocean did not just lose its inhabitants. It lost the architecture that made inhabitation possible. Recovery required building that architecture again, from scratch, in the dark, at the bottom of an acid sea. Volcanic eruption line. The ring of fire runs along the edges of the Pacific Ocean, a chain of volcanoes and fault systems so geologically active that it produces approximately 90% of the world's earthquakes. Most people consider it the most dangerous volcanic system on the planet. It isn't. The most dangerous volcanic systems on Earth are the ones you cannot see, buried beneath the ocean floor itself, erupting in total darkness at pressures that crush submarines. And they have been responsible for 4 of the 5 greatest mass extinction events in Earth's history. They are called large igneous provinces, and they represent something different from ordinary volcanism. Where a standard volcano punches through the crust at a single point, a large igneous province floods vast regions of the ocean floor with magma from mantle plumes rising from deep within the Earth. The Ontong Java Plateau in the Pacific, the largest known example, covers approximately 2 million square kilometers and was built in 2 eruptive phases, roughly 122 million and 90 million years ago. Its scale is difficult to visualize. It is larger than continental Europe. When submarine large igneous provinces erupt, they release massive quantities of carbon dioxide and sulfur dioxide directly into the ocean. The result is simultaneous ocean acidification and ocean anoxia, a chemical double strike that strips the water of oxygen while making it corrosive to the calcium carbonate structures that form the foundation of marine food chains. Volcanologist Paul Wignall of the University of Leeds has spent decades documenting the correlation between these eruptions and mass extinction events, describing large igneous provinces as, in his assessment, the most reliable kill mechanism in Earth's history. The Caribbean Large Igneous Province, erupting approximately 89 million years ago, is directly linked to a global marine die-off called Oceanic Anoxic Event 2, whose signature, a band of black oxygen-depleted shale, appears in ocean sediment cores worldwide. The mid-ocean ridge system, 65,000 kilometers of continuously active underwater volcanic chain, is the longest geological structure on the planet. In a given year, more volcanic material is expelled along the ocean floor than from all continental volcanoes combined. This baseline level of oceanic volcanism, which we consider normal, would constitute a planetary emergency if it were visible. But it happens in the dark, beyond monitoring, at depths no instrument has fully surveyed. We have mapped less than 25% of the ocean floor. The volcanic systems operating in the unmapped remainder are not hypothetical, they are active. The only question our instruments cannot yet answer is how active. The ocean floor has killed the world before, through mechanisms that left no surface warning. It is doing what it has always done. Right now, in the dark, at a depth where the concept of warning is purely academic. Deep impact wave. In 1981, geologist Frank Kite was studying deep sea sediment cores extracted from the floor of the Southern Ocean when he found something that had no geological explanation. A layer of glass spherules, shocked minerals, and osmium isotopes consistent with extraterrestrial origin, sitting in sediment dated to approximately 2.5 million years ago. An asteroid had struck the ocean, and in the 2.5 million years since, nobody had noticed. The Eltanin impact event is the only confirmed large asteroid strike with deep ocean in Earth's recorded geological history. The impactor is estimated to have been between 1 and 4 kilometers in diameter. It struck water approximately 5 kilometers deep in the Southern Ocean south of Chile. Because it hit deep water rather than land or shallow sea, it left no crater. There is no visible scar on the seafloor. The evidence of its existence is a thin chemical whisper in the sediment, iridium and osmium isotopes pressed between layers of ordinary oceanic clay, detectable only to someone specifically looking for it. Computer models developed by researchers including Galen Geisler suggest the Eltanin impact generated an initial wave with heights potentially exceeding 200 meters, larger than any wave produced by a confirmed geological event in human history. For comparison, the 2004 Indian Ocean tsunami, which killed approximately 230,000 people, produced initial waves of roughly 30 meters. The Eltanin wave would have reached the coasts of South America, Antarctica, Australia, and South Africa within hours of impact. The sediment record shows evidence of massive disturbance across a wide radius. The full extent of the environmental damage is, because of the impact location, extraordinarily difficult to reconstruct. Some researchers have proposed a connection between the Eltanin event and a documented period of intensified glacial expansion in the late Pliocene, suggesting the impact may have pushed the climate toward a threshold it was already approaching. That connection remains debated. What is not debated is the statistical implication of the Eltanin discovery. Asteroid impacts cover the ocean floor, which represents roughly 70% of Earth's surface, at a far greater rate than they strike land. We have identified almost none of them. The Eltanin event is not the anomaly. There is no crater at Eltanin. There is no monument. There is only the sediment, and the sediment does not care whether we are paying attention or not. Every impact that struck deep ocean before we developed instruments sensitive enough to read the chemical record is, by definition, invisible to us. We are reconstructing the bombardment history of our own planet from a sample size that may represent a fraction of 1% of what actually happened. Mega tsunami. On the island of Santiago in the Cape Verde archipelago, geologist Ricardo Ramalho found marine fossils and ocean sediment sitting 270 meters above sea level. Not 27 meters, not 70 meters. 270 meters above the current ocean surface on the side of a rocky island in the middle of the Atlantic. The only mechanism capable of depositing ocean material at that altitude is a wave so large it has no modern equivalent and no historical name. The event Ramalho and colleagues documented in Science Advances in 2015 was generated approximately 73,000 years ago by the collapse of the Fogo volcano on the neighboring island of Fogo in the Cape Verde archipelago. The volcanic flank gave way. An estimated 160 cubic kilometers of rock and debris struck the Atlantic in what amounts to geological terms to a single instant. The ocean responded the way a full bathtub responds when something large is dropped into it. Except the bathtub was an ocean, and the wave it produced was 240 meters tall. For comparison, the 2004 Indian Ocean tsunami killed approximately 230,000 people, with initial waves of roughly 30 meters. The Fogo wave was approximately 8 times taller. Current tsunami warning infrastructure was not designed for an input at that magnitude. The detection systems, the evacuation protocols, the modeling frameworks, all were calibrated against the disasters humanity has already experienced, not the disasters the geology is capable of producing. Volcanic flank collapses are not rare anomalies in the geological record. They are a standard feature of oceanic island geology. Every island with a large volcano sitting on an unstable foundation is, in geological terms, a countdown. The Canary Islands, and specifically the island of La Palma, contain a fault system whose potential western flank collapse has been modeled by researchers including Simon Day and Stephen Ward. Their 2001 study suggested a La Palma collapse could send waves of considerable height toward the United States East Coast, though subsequent research has significantly contested the scale of that projection. The debate about magnitude does not resolve the underlying geological fact. The mechanism is real. The countdown is geological, measured in tens of thousands of years, not centuries. The marine fossils sitting 270 meters above sea level on Santiago are not a geological curiosity. They are a record. The ocean delivered something to that altitude once, deposited its contents there with perfect geological indifference, and then retreated. The fossils are still there. The receipt, it turns out, is permanent. Oxygen crisis. 2.5 billion years ago, the ocean committed what can only be described as an accidental planetary murder. Life had existed in the seas for over 1 billion years before this moment. Simple, ancient bacterial life that had never encountered free oxygen. Oxygen was not the air. It was not the atmosphere. It was a poison, and the microorganism that began producing it in earnest was doing nothing more sophisticated than eating sunlight and exhaling. The exhaust of that process killed almost everything alive on Earth. The organism responsible was the cyanobacterium, photosynthetic bacteria that colonized shallow ocean environments and began converting sunlight and carbon dioxide into energy, releasing free oxygen as a byproduct. The ocean initially absorbed the oxygen, which reacted with dissolved iron in the water and precipitated out as iron oxide, forming the vast banded iron formations found in ancient rock sequences across every continent on Earth. Those red and gray striped rock layers are, in a very literal sense, the rusted remains of the first atmosphere the ocean tried to contain. Eventually, the iron ran out, and the oxygen had nowhere to go but up. The Great Oxidation Event, occurring approximately 2.5 billion years ago, and studied extensively by researchers including Heinrich Holland of Harvard, fundamentally transformed the chemistry of the atmosphere and the ocean simultaneously. The obligate anaerobic organisms that had dominated Earth's biosphere for over 1 billion years found themselves living in an increasingly toxic environment. They could not adapt quickly enough. The event wiped out the dominant life forms on the planet in what may represent the most complete biological transformation in Earth's history, replacing an anaerobic world with one chemically dependent on the very substance that had been lethal. The Huronian glaciation, Earth's earliest known global ice age, followed directly as methane produced by the dying anaerobic organisms was oxidized and destroyed, removing its greenhouse warming effect and plunging the planet into a deep freeze. The depth layer here is almost too strange to process. The cyanobacteria that caused the Great Oxidation Event did not go extinct. They persisted, diversified, and were eventually incorporated by other cells in a process called endosymbiosis, becoming the chloroplasts inside every plant cell alive today. The organisms that committed the greatest mass extinction in Earth's history are now the biological engine that produces every molecule of oxygen in the atmosphere you are breathing, The ocean's greatest killer became the source of all breath. The air filling your lungs right now is the exhaust of a catastrophe. It is the chemical byproduct of the most complete mass extinction this planet has ever experienced, produced by organisms so small they are invisible, and so successful they remade the world. Something had to die so completely that the atmosphere itself changed. And from that death, everything you know became possible. The ocean did not intend any of it. It simply ran the chemistry, indifferent to the outcome, as it always has. Ocean Memory Event. 55 million years ago, something heated the deep ocean by 5 to 8 degrees Celsius in fewer than 20,000 years. In geological terms, 20,000 years is an eye blink. The event is called the Paleocene-Eocene thermal maximum, and it is the most studied rapid warming event in Earth's deep time record. It is also the event that climate scientists return to again and again when they need to understand not what warming looks like in a model, but what it looks like written in stone, in sediment, in the dissolved remains of trillions of organisms that did not survive the chemistry. Before the Paleocene-Eocene thermal maximum, the deep ocean was already warmer than today. The planet was in a greenhouse state. No permanent polar ice caps existed, but the deep sea had its own complex, stable ecosystem, a world of benthic foraminifera, microscopic single-celled organisms that built calcium carbonate shells and lived on the ocean floor in extraordinary diversity. They had no warning system. There was nothing in their evolutionary history that prepared them for what the chemistry was about to do. An estimated 2,000 to 10,000 gigatons of carbon were released into the atmosphere and ocean within a geologically brief window. The source remains debated, with candidates including massive volcanic activity, the destabilization of methane hydrate deposits, and a bolide impact. What is not debated is the result. Ocean acidification became so severe that calcium carbonate sediment began dissolving from ocean floors worldwide. The shells of trillions of marine organisms, accumulated across millions of years, dissolved. The sediment record at the onset of the event shows not the ordinary white calcareous ooze of the deep sea, but a distinctive red clay layer, the chemical residue of a floor stripped of everything that had built up on it. Approximately 30 to 50% of deep-sea benthic species disappeared. James Zakos of UC Santa Cruz, whose research on Paleocene-Eocene thermal maximum ocean chemistry has been foundational to modern climate science, has described the event as the closest geological analog to what carbon emissions are currently doing to ocean chemistry. The recovery took approximately 200,000 years. The detail that makes this entry genuinely disturbing is one of scale and rate. The carbon release during the Paleocene-Eocene thermal maximum was catastrophic enough to dissolve ocean floors and drive a mass extinction. And yet geologist Lee Kump and colleagues have published work noting that the modern rate of carbon input to the ocean atmosphere system has no clear geological analog in the past 300 million years. The Paleocene-Eocene thermal maximum is our closest comparison. We are moving faster than it did. The red clay layer in the sediment record is the dissolved remains of an ocean's worth of shells. Trillions of organisms pressed into nothing because the chemistry changed too fast. The ocean does not editorialize. It does not warn. It records. And the record of the Paleocene-Eocene thermal maximum sits in cores in laboratories around the world, a detailed description of a future written in the past, waiting for someone to read it carefully enough to understand that the ocean has already written the ending. It wrote it 55 million years ago. The chapter heading was Dissolution. Abyssal Silence Event. At the bottom of the ocean, below 6,000 meters in the region scientists call the Hodl Zone, the pressure reaches over 1,000 times what exists at the surface. A submarine sent to that depth without precise engineering would be compressed in seconds. The darkness is absolute, permanent, and has existed unbroken for billions of years. No sunlight has ever reached it. No surface storm has ever disturbed it. And yet it is not empty. Something lives there. Something that has lived there, according to the fossil record, through every single catastrophe on this list. Through the asteroid, through the volcanic floods, through the oxygen crisis, through the dissolved floors and the frozen currents and the 240-meter waves. Whatever is in the abyss did not notice. It simply continued. The Hadal Zone covers approximately 45% of the ocean's depth range and has been directly explored in a fraction of 1% of its total area. The 5 Deeps expedition in 2019 completed the first comprehensive survey of all 5 major ocean trenches. James Cameron made a solo dive to Challenger Deep in 2012, reaching approximately 10,935 meters. In 2023, scientists from the Schmidt Ocean Institute documented snailfish at a depth of 8,336 meters in the Izu Ogasawara Trench, the deepest fish ever recorded, alive, active, and apparently thriving in conditions that should, by most biological frameworks, make complex life impossible. Microbial life has been recovered from ocean sediment at depths exceeding 2.5 kilometers below the seafloor itself. Organisms living without sunlight, metabolizing at rates so slow they exist in a state with no surface analog. In 2020, researchers published findings in Nature Communications, documenting microorganisms recovered from deep sea sediment cores in the South Pacific Gyre that had been in a dormant metabolic state for approximately 100 million years. When provided with nutrients in a laboratory setting, they resumed normal metabolic function. They woke up, 100 million years in the dark, in sediment, at extreme pressure, and they woke up. The researchers published the finding. No consensus exists on what it means for the definition of life itself. Geobiologist Tara Jokic and colleagues have proposed that life on Earth may have originated not in shallow thermal pools, but in deep-sea hydrothermal vent systems, meaning the abyss may be simultaneously the origin point and the last refuge of life on this planet. Every other environment on Earth has been sterilized at some point in geological history. The deep ocean, stable in temperature and pressure for hundreds of millions of years, may be the one place that never was. We have mapped Mars in higher resolution than we have mapped the floor of our own ocean. We sent rovers to another planet before we sent a vehicle capable of sustained observation to the deepest point of the one we live on. Whatever is in the permanent dark below, whatever has survived every extinction, every acid bath, every frozen ocean, every impact wave, every volcanic flood documented in 4 billion years of geological record, it is not waiting to be discovered. It has been there the whole time. In the silence, in the dark, without us. And the most unsettling possibility is not that it is alien to us. The most unsettling possibility is that it was here first, and when everything else is gone, it will still be here last. 10 events. 10 moments when the ocean demonstrated that it operates on a set of rules that human civilization has never fully accounted for. The pattern running through all of them is not chaos. It is indifference. The ocean did not target life. It did not spare it. It ran its chemistry, its pressure, its volcanic systems, and its currents according to laws that existed long before anything with eyes evolved to watch them operate. What makes these events terrifying is not their scale, though the scale is staggering. It is that every single mechanism responsible for them is still active. The hydrates are still frozen on the shelf edges. The mantle plumes are still rising beneath the ocean floor. The AMOC is still slowing. The deep sea sediment is still dissolving where the chemistry is wrong. The ocean is not a historical document. It is a living system, and history, in this case, is what it does when the conditions are right. Every civilization that has ever existed has built itself on the assumption that the ocean will remain approximately as it is. The geological record suggests that assumption has a time limit. Comment below with the entry that convinced you the most. the one that feels less like prehistory and more like a forecast. The abyss does not announce itself. It does not build toward a climax. It simply waits, in the dark, at depth, with a patience measured in geological time. Subscribe, because the ocean is still keeping records, and most of them have never been opened.